In this video, let us set up an interactive system to control the speed and direction of a DC motor. We are using two of our products, Automator Interactive, which is our PC application software with visualization tools, and T7000P, which is our signal generation and acquisition hardware. Here is a preview of this demo. Based on the position of the slider control bar, the speed and direction of the DC motor changes. We have a follow-up video which demonstrates the full automation of DC motor testing with the click of a button. The link for that video is given in the description field below. Note that the purpose of this video is only to demonstrate the usage of our products. In case you are new to our products, please visit our website for more details. Let us get started with the high-level connection diagram of this demo. Here is the DC motor. And this is T7000P, which is connected to the PC with Automator via Ethernet. LM2596S is a DC-DC buck converter for generating 5-volt supply. L298N is a dual H-bridge motor driver module for controlling the DC motor. LM393 is a sensor module to measure the speed of the DC motor. The speed and direction of the DC motor is determined by the output voltage of L298N. As this voltage goes up, the speed of the motor goes up. As this voltage drops, the motor speed goes down. And when the polarity changes, the motor starts rotating in reverse direction. The magnitude of this output voltage is determined by the duty cycle of the pulse signal on the ENB line. And the polarity of the voltage is determined by the voltage levels in IN3 and IN4 lines. We are using PO3 of T7000P to provide a pulse signal to ENB line. PO4 and PO5 are used as digital outputs to provide signals to IN3 and IN4. In order to control the speed and direction of the DC motor, we only need to control the PO3, PO4, and PO5 signals. The LM393 sensor module generates a pulse signal, the frequency of which is proportional to the motor speed. The frequency of this pulse signal is measured using PI1 of T7000P. Here is the actual setup. This is the DC motor. This is the L298N driver module. This is the LM393 speed sensor module. The fan connected to the motor shaft is positioned in such a way that the fan leaf passes through the sensor module as it rotates. Each time the leaf passes through the sensor module, a pulse is generated. Continuous rotation of the fan results in a pulse train, the frequency of which is proportional to the motor speed. This red wire is the 5-volt line coming from the LM2596S converter. This yellow wire is the VSys from T7000P. And this black wire is the ground. These three blue wires are pulse signals, which are connected to PO3, PO4 and PO5 of T7000P. These two wires are outputs of L298N, which are connected to the DC motor. This green wire from LM393 is connected to PI1 of T7000P. And T7000P is connected to the PC using Ethernet. Next, let us set up an Automator interactive project. Here the device T7000P is already added and is set online. Unlock the project to add the widgets. Now, open the widget tree. The easiest way of generating pulse-out signals is by using the pulse-out widgets of T7000P. Drag and drop 3 pulse-out widgets, a pulse-in widget, and a status box widget. Resize the widgets as needed. Lock the project. For pulse out and pulse in widgets, select the device to which the widget events need to be directed. For pulse in widget, enable PI1 to start the acquisition of input signal. Set the channels in the pulse out widgets as per the connection diagram explained earlier. A frequency of 50 Hz is good enough for the motor. The default duty cycle can be left at 0. For status box, select the signal to be displayed. Here is the Python code in the device interface file that converts the PI1 frequency to RPM, which will be displayed in the status box. We are ready to control the motor. Now, turn on the widgets. Set the duty cycle of P04 and P05 to set the direction of the motor. In the oscilloscope capture, channel 1 is connected to P03 and channel 2 is connected to PI1. Change the duty cycle of P03 to change the speed of the motor. See the corresponding changes in the oscilloscope. The motor speed in RPM is also displayed on the status box widget. Next, let us change the direction of the motor by changing the duty cycle of P04 and P05. Now, change the duty cycle of P03 to start the motor. As expected, the direction of the motor changed. So, we achieved the goal of controlling the motor speed and direction. Now, let us try this with much more user-friendly widgets. Into the page, drag and drop a slider control widget for controlling the motor. Next, drag and drop a circular dial widget for displaying the motor speed. Resize and rename the widgets as needed. Right-click and configure the slider control to change the min value to -20 and the max value to 20. For the slider control widget, select the device to which the widget event needs to be directed. Next, right-click and configure the circular dial. For the circular dial widget, select the signal to be displayed. As the user moves the slider control bar, the position information of the bar gets passed on to the corresponding device interface file. The Python code in the interface file translates this position information to duty cycle values. These duty cycle values are sent to the respective pulse-out channels of T7000P. Here, the sign of the value determines the direction of the motor and the magnitude determines the speed of the motor. Note that the frequency is hard-coded to 50 Hz. With this code in place, the user can move the slider control bar to control the speed and the direction of the motor. As we move the slider control bar, we can see the change in motor speed in the circular dial widget. This completes the interactive mode demo. Hope you enjoyed this video. Setting up an interactive system or a full automation system is very easy and affordable with our products. We do have plenty of other example videos on the usage of our products. Thank you for watching. For more information, please visit us at www.texarsystems.com or contact us through phone or email.